Welcome everyone. Today we are going to dive deeper into the technical aspects of computing. We'll cover the internal workings of the CPU, how data is represented and secured, and finally, the fundamentals of computer networks and the World Wide Web. Let's start with the central processing unit. The CPU consists of several key internal components. First, we have the control unit, the CU. You can classify the CU as the computer's central traffic controller. It adjusts the flow of data and retrieves memory based on instructions. It retrieves instructions and decodes them to tell other parts of the CPU what needs to take place. Next is the arithmetic logic unit, ALU. This component performs all calculations. It handles arithmetic operations like addition and division, as well as logic operations, comparing if one number is greater than or equal to another. Finally, we have registers. These are small, fast storage locations found within the CPU. They hold the data that the ALU is currently processing. The CPU is best understood by how it executes instructions. It uses a process generally known as the fetch, decode, execute cycle. First, in the fetch stage, the control unit fetches the next instruction from memory, the RAM. Second is decode. The CPU works out what needs to occur, for example, adding two numbers or retrieving stored data. Third is execute. The CPU signals the relevant part of the computer, such as the ALU, to actually perform the instruction. This process happens billions of times every second. For instance, a 3 GHz CPU can perform this cycle 3 billion times per second. A computer comprises a collection of components that continuously signal each other to perform tasks. Let's look at the example of opening a web browser. It starts with input. You double-click the web browser icon. This sends a request to the CPU. The CPU fetches the necessary data from the hard disk. These files are then loaded into memory, the RAM. The CPU processes these instructions directly from RAM and executes calculations in the ALU. Finally, the output is sent to the monitor so you can see the web browser open. Input, processing, storage, and output devices all work together to complete this task. Now we need storage devices to store our data and programs. There are three main types of storage media. Magnetic storage, like hard disk drives, uses magnets to hold data on a spinning platter. They are inexpensive and offer high capacities, making them great for desktops and servers. Solid-state storage, like SSDs, use flash memory chips. They are much faster and longer-lasting than hard disk drives, though more expensive. Optical storage uses lasers to read and write data. While less common for personal storage today, they are still useful for distributing movies and software or for long-term data archiving. A computer doesn't understand letters or images. It only understands binary. Electricity being on, which is the number 1, or off, which is the number 0. A single digit is a bit. A group of 8 bits is a byte. By combining bytes, we can represent anything. To ensure all computers understand text the same way, we use standardized systems. ASCII is a basic system using 1 byte per character. Unicode is a more current system that can represent characters from nearly every language and even emojis. Encryption consists of converting plain text into ciphertext. It utilizes a mathematical algorithm and a secret key to transform data. For example, if we send hello, plain text, and use a simple key like move every letter forward 3 places, it becomes KHOOR, KHOOR, ciphertext. To read it, the recipient uses the key in reverse to decrypt it. While real computing keys are far more complex, this concept is vital for internet banking and password storage. All media in a computer is stored in binary. Images consist of millions of tiny dots called pixels. A common method is TrueColor, which allows 24 bits per pixel, representing over 16 million different colors. Sound requires sampling. Microphones convert sound waves into electrical signals. An analog to digital converter measures the height of these waves thousands of times per second and saves them as binary numbers. When played back, a DAC reads those numbers to recreate the sound wave. Compression reduces file size to save space and speed of transfers. There are two formats of compression: lossless compression and lossy compression. Lossless compression finds patterns to store data efficiently without losing anything. It is essential for text or software, where losing data would corrupt the file. Lossy compression, on the other hand, permanently removes data that humans likely won't notice. This is perfect for media like JPEGs or MP3s, or a perfect replica isn't strictly necessary. Logic gates are small electronic switches on digital circuits. They take binary inputs and produce a binary output based on logic rules. By combining billions of these, CPUs perform complex tasks. The three fundamental types of logic gates are AND gates, OR gates, and NOT gates. AND gates requires both inputs to be true. OR gates requires at least one input to be true. NOT gate simply inverts the input. Networks are categorized by size. A LAN covers a limited area, like your home or an office building. A WAN covers a vast area. The Internet is essentially the largest wide area network, connecting smaller networks globally. A MAN falls in between, typically covering a city, such as a network connecting various municipal buildings. To share data, we need specific hardware and software. Hardware includes the NIC inside your computer, switches that connect devices within a LAN, and routers that traffic data between networks, like your home to the Internet. Software includes the network operating system and protocols like TCP and IP, which define how data is broken into packets and addressed to the correct destination. For transmission, we use Ethernet cables for short distances, fiber optics for long, fast distances using light, or Wi-Fi for convenience using radio waves. The World Wide Web relies on diverse technologies working together. HTML is the language used to build the page structure. HTTP is the protocol used to transmit that page to you. The web browser interprets the HTML to display these pages, and the URL provides the unique address to find that resource. Topology is the structure of a network. The star topology is the most commonly used network topology today. All devices connect to a central switch. It is reliable because if one device's cable breaks, the rest of the network is unaffected. Older topologies include the bus, a single central cable, and the ring, devices connected in a circle. These are generally considered less reliable because a break in the main cable can take down the entire network. Here is the list of academic and technical sources used to compile this presentation. Thank you for listening.